Hello everyone, here is Henriette Dybkjær from MDC. We are kickstarting this week's Tidbits. We celebrated 1 month of Tidbits last week, where we could celebrate 491 people who had attended Tidbits in only 1 month. So I hope it's okay, but we're really proud of that, and we have people logging in from all over the world. So it's really amazing. It's we dare to call it a little success so far. But today we have one of my wonderful colleagues in the Tidbit studio. It's my colleague Jan Boyesen, and he has been an MDC for a few years, but the last year he has been working on a very, very interesting project called Decarbonize. You can, of course, hear what it's about, decarbonizing the emissions of the ships, but what I'm looking so much forward to hearing about is that it's something about huge ice cubes or ice pigs or something like that, and they're going to be dropped to the in the deep sea. But I'm not going to explain anything more about that. I'll just pass over the floor to Jan, and he will tell me like skift, because we had some technical problems. So I'm going to run his PowerPoint presentation. So please don't listen to when Jan is telling me to change a slide. Jan, I will bring you up on the full screen now.
Thank you for that, Henriette.
15 minutes talk, Jan, and then 15 minutes Q&A.
Yes.
Welcome, Jan.
Good. Yes. Hello, everyone. My name is Jan Boyesen. I'm head of development. Can you hear me?
Yes, it's okay.
Yes. Yeah, I'm head of development at the Maritime Development Center, and I'm also the project manager of the Decarbonize project, which has been running now for 7 months. And basically, the Decarbonize project is a global collaboration with 8 ship owners from all around the world, and also producers of equipment who are working on developing this new radical innovation that we have developed at the Maritime Development Center. And basically what we're working on is on, as the name says, decarbonization. Most concepts are focusing on the fuels. We have taken another approach about how you could decarbonize the shipping industry, and that is carbon capture and storage. So in that sense, it's kind of another way of reducing CO2 emissions. Of course, it's a very big challenge. Shipping emits about 1 billion tons a year of CO2, so it's a really intense CO2 emitter, you can say. So it's also a very big challenge, which we have been seeing when we are looking into the size of the equipment and the magnitude of the things that we are looking at. So basically, we do this in 3 steps. The first step is to catch the carbon from the exhaust gas. You can use our solution on existing ships and existing fuels, but basically we have these 3 steps. So the first one is to catch the CO2, and we're looking at various technologies of these. It has been already worked on the land-based installation, so you have had carbon capture, but of course bringing these into a maritime context is different, and therefore we need to figure out ways of doing that. We have lower temperatures, we have lower concentrations of CO2, and we also have less space.
Yeah, your presentation, sorry?
Sorry?
Your PowerPoint.
I can only see it as a small...
Do you need your PowerPoint in big?
You can start by showing the main page. That will be fine, yeah.
Good.
The second step is to produce these big, you could call them ice-torpedos, we call them carbon descent vehicles, out of solid CO2, and then creating a system to launch these into the sea. Because the density of the dry ice, the CO2 ice, is higher than for seawater, they will go down to the seabed and penetrate the seabed sediments. But I will explain this more into detail if you go back 1 slide, Henriette. So as I said, this is a joint industry project. It has partners from all over the world. We have calculated that we have about 20% of all the tonnage in the world is supporting the project. It's funded by the shipping companies, and then the technology companies are providing knowledge on the different components. What we're working on, or the goal you can say, is a proof of concept of the technology. It's also getting the necessary regulatory approvals for doing this. And apart from industry, which is the driver of the concept, we also are working with various researchers, knowledge institutions, and so on, in order to show that our concepts are valid, our results are valid, and of course also to help us improve the different concepts and parts of the project. But this is some of our partners, and as you can see, they're all over the world. So it's Ardmore Shipping from Ireland. We have BV Group. We have Clean Marine, DSME, Knudsen from Norway, and NYK, the Japanese shipping company, as well as Softcomflot, TK, and Vale. And we're also in very close dialogue with Costco Shipping, I can say. If we flip to the next slide. And by the way, I can say that overall, we're a non-profit initiative. We are not taking any IP on this. We have published the basic idea in a newspaper. So we are not pursuing any kind of IP rights in the consortia. So it's an open platform, and we really want the companies to develop the technology very fast. And that's why you can say we have established it in this open innovation way, because we're also a pre-competitive stage, you could say. As we get the concept more in place and we start getting the permits to do this, hopefully, then of course we will see more kind of protection of the ways on how to catch the carbon and how to release it to the sea and so on. But that's not the stage where we are right now. We have illustrated the concept here roughly on how we do this. So you can see it's the carbon capture. We take the plume from existing ships. And one interesting aspect of our concept, I think you can see if you look at the 3 barrels, is that it looks with existing fuels. And of course, that is very good because we can retrofit it on existing ships. And as everyone knows, since the lifetime expectancy of many of the existing ships is quite long, then it's really good that we can do something right now. And we expect about 70% of carbon capture, so a reduction of 70% from shipping. This depends a lot on, you can always clean it to a very high level, but there will be a penalty on energy consumption. So for practical reasons, we want not to have, say that we are going on a very high figure, but because then the OPEX on that will be kind of not so positive. And but another aspect of this is that if we use it on biofuels, then it will actually be a carbon negative solution. And this is very cool because then we're actually removing CO2 from the atmosphere, since the biosource that you use to produce the fuel has captured the carbon, and then the carbon is stored in the seabed sediments. So this is a little bit unique for our solution also. Maybe we can go to the next slide. So here, this is the cartoon, and on more kind of a systematic way, we have several work streams in the project. So we have onboard technologies. We have the carbon transport. Then we have the regulatory approval, and finally we have the project management. But I will not go into deep. We have several work streams and people working on these areas, of course. So we have a lot of new and interesting activities going on. If we skip to the next slide. Can we go to, yeah. So luckily, it's not only me doing all the work. I have a team that helps me on this. And of course, my chairman, as you might know, is Henrik O. Madsen, former CEO of DNV GL, and he has really been very supporting of the project. I also have Mikkel, my CEO, who is supporting internally a lot. And then we have Ivar Molke, who is kind of the inventor and the guy that came up with combining these 2 ideas of carbon capture on the one hand and the storage in the seabed sediments on the other hand. And then I have several others. We also have some, as I said, some researchers that are not in this slide, which we are collaborating with. There is a question here. Can I please ask a question for afterwards? Yeah, please, if you have questions, please put them in the side, and yeah, then we can take that one. But can we go to the next slide, please? So, as I said, this can be mounted on existing fuels and existing ships, and that is really an attractive thing, since we have so many assets out there already that you can prolong the life expectancy of these. And I think that's kind of a very supportive part of the business case, is that you can actually prolong the utilization of current assets, and that will be very attractive, because you can at the same time comply with the requirements of the 250. We initially are looking at the deep sea vessels, and the reason, there's two main good reasons for that. One is that of course deep sea ships consume by far the largest proportion of fuel, so thereby we are attracting a very big part of the market for decarbonization. You can also say a lot of the solutions that we're seeing, batteries and other things, are very well suited for shorter distances. But kind of when we're talking about this massive consumption of energy, then there are not that many solutions. The other good reason for that is that we need a deep sea under us in order to store the CO2, and I will come into that. But it doesn't work on you need at least 500 meters, and maybe we're closer to 3,000 meters actually, in order to have a safe storage of the CO2. And therefore, we really should focus on the deep sea trades. Yeah, and as I said, if you combine it with the biofuels, then you actually have a carbon negative solution where you're actually removing CO2. So I think, since the IPCC has also, the climate panel has been looking at carbon capture now, and saying that this probably is a solution for the future, since we probably would have emitted too much CO2 already to the atmosphere. So this could be a game-changing technology for that. If we go to the next slide. One of the analogies we are taking is that we look at how the sulfur cap was implemented. So basically, there was a lot of talk of new fuels, LNG, very low sulfur oil, and so on. At the end of the day, because of the high infrastructure costs that you have on that, and that you need other industries to do the investments, we saw that the industry itself acted on the use of scrubbers, which were financed by the industry itself. And we say, when we look at this 2050 requirements on carbon, we believe that focus should not only be on new fuels entirely, because the history has shown that the industry itself might look other ways. So therefore, looking back at what happened with the global sulfur cap, we believe that that it's important to have several technology pathways open, because the industry will benefit from that on the long run. If we go to the next slide, and I can see I need to speed a little bit up. So basically, we have three key technologies for doing this. The first one is freezing down or cooling the exhaust gas, and we do that, or planning to do that, in 3 steps. So with different coolants, and we will go from about 200 plus to 130 minus degrees in order to capture the CO2. So the first coolant will be seawater, of course, and we also then will use kind of an industrial coolant, and finally we might use liquid LNG. But we are really looking into this a lot, because we want to have a low energy penalty on doing this. We have calculated that the energy penalty for cooling on bunker fuel or existing fuels will be 10%, so MGO, and on LNG it will probably be 7% of increased energy utilizations, because then you can use the coolness from the liquid LNG to cool down the exhaust gas. Then the next part is, of course, creating the carbon descent vehicles. we are looking at many different shapes and have a team calculating on how the shape should be and the size and so on. Right now we are looking a lot at a CDB design which looks actually like a water drop, you could say, about 1 to 2 tons. And then finally we're looking into various launch systems. We need to make sure that it doesn't crack when it enters the seawater. So we need to have some solutions on that. The next slide. Yeah, and as I said, expected energy penalty about 10% on HFO, MGO, and 7% on LNG. The technology has been proved already on power plants. So, but the characteristics of the exhaust gas is different for ships. We don't consume chemicals, so we're not into this amine business that's a lot of carbon capture projects are working on, where you have chemicals to catch the CO2. And we're looking a lot of the existing patents and research that has been done in this area. But a lot of the work in this area is also on engaging manufacturers and developers of the equipment in order to develop this further. Right now we're mainly focusing on kind of the minimal viable product, you could say. We just need to make it work. If we can go to the next slide. Then we have how does this actually work down in the seabed sediments? And as I said, it has a higher density, the ice, than water, so it will go down. Here it says 20 meters per second. Actually, our new calculations based on these new shapes are saying 30 meters per second, so they will have quite a high speed. And if you look at the seabed sediments, they're kind of containing water and soft, so they're not like very solid like soil you will expect here on the earth. Down in the sea, they're much more soft. So the basic concept is that when this enters the seabed sediment, then it will push them aside and penetrate the seabed sediments, and then it will get covered on top again with the sediments. And what happens down there is that, of course, the ice starts to melt. When it does that, the water molecules, they bind physically, not chemically actually, with one molecule of water. One molecule of CO2 will take 6 molecules of water and be bound in something you call CO2 hydrate. And this is a stable way of actually storing the CO2. If you're beyond 2,800 meters, then the liquid CO2 would also be heavier than water, but the hydrate is heavier than water. So that's why we know that it will stay down. It's basically simple physics. So what will happen is that a crust of hydrate will be formed around the CDB. Then as the ice keeps melting, because the liquid CO2 is less dense than the ice, then it will crack on the surface, and this will keep on working for some time, maybe a day or something like that, until it has been stabilized, the temperature, the pressure, and then it will be a liquid CO2, and you will have a crust, a hard crust of hydrate around it. And then this is something that the geological survey here in Denmark is helping us actually confirm our calculations in this area, that it will actually stay down there. The hydrate is heavier than water, so it will stay within the sediments. And basically there is much more carbon in the seabed sediment already than there is in the atmosphere. So basically we're reproducing a process that is happening naturally already, and as such, it's not an unknown thing for the seabed to have this hydrate. If we can go to the next slide. Yeah, so here we have some of the principles on the binding the CO2 as hydrate in the seabed sediment. So I think we can skip this one and go to the next one. One of the things we're also working on is that we're actually testing, we're producing dry ice, CO2. This is what you're seeing here, and maybe if you can go to the next one. Technologisk Institute here in Denmark is doing research on this. So they're freezing CO2 out of the exhaust, or this is actually not from the exhaust, but they're freezing CO2 out and putting water on it and putting it into water and see kind of the mechanical properties and the physical properties of the ice, because we need to make sure that it's strong and that it can go down. So yeah, we can go to the next. That's fine. And then we're in association with a geologist looking into where can you actually safely store this. As I said, you need minimum 500 meters, and that's about 85% of the surface of the ocean. So we have a lot of places to do this. And of course, one of the things we're looking into is if the general trade routes, how do the depth in these areas provide the storage that we need. We can go to the next one. Yeah, and so one of the things will also be to mount sonar on board of the ship in order to make sure that you're actually sailing above something that is soft and where you can store the CO2. We can go to the next. I think I'm running low on time. And as I said, we are also calculating various shapes of the CDV, the ice torpedo, in order to get the optimal length, weight, and speed. Next one. Then the final track, working track, of course, you need an approval to do all this. So we basically have two areas where we need approval. One is that we need the approval of the equipment on board of the ship. But another thing is that we need approval according to the London Convention in order to, because you're of course not allowed to pollute the sea, so you're not allowed to throw waste into the sea. But CO2 as such is not waste, but we need a permit according to the London Convention. So what we are working on right now is to present our concept to the IMO's London Convention in order to get the approval for storing the CO2 in the seabed sediments. And you can see here our advisor on regulatory affairs, as well as one of the members of the board of directors of the project. The CEO of Sovcomflot is meeting here with the Secretary General of the IMO, together with the Russian delegate as well. So we are already in a dialogue with the IMO, and that will be the next thing to present for the scientific committee of the London Convention, to present our results in order to get the permit. And basically, I think that concludes my presentation. I think I went a little over time. Sorry for that, Henriette, but I hope it's okay. And then I would like to know if there is anyone that has any questions or comments.
Hello, Jan, again. Yes, thank you so much. Very interesting finally to see also the latest developments of the project. I had not seen the physical items from the Technological Institute. Very interesting also to see that it's really getting something tangible.
Yes.
So, let's just get started with a few questions, because Thomas Clausen, he's asking, great presentation, thank you. What are the risks of storing CO2 in the seabed? That's a very good question.
You can say seabed sediment storage is by far less risky than storage in geological formations, as the one you are working on in Nord Stream and on other places where you say that you will take all the oil wells and you will pump in CO2 at a very high pressure, because if that cracks, then you will have a massive problem. You can say here we are spreading blocks of 1 to 2 tons to the seabed. So let's say that a CDV does not penetrate the seabed sediment, but it actually somehow lands on top of that. We're really calculating a lot and making sure that will not happen, but eventually that will happen. Then what will happen is that if it's below 2,700 meters, by the law of physics, the CO2 will stay in the seabed. So it was just heavier than water, it will just stay down there in the seabed. If it's less than 2,700 meters, up to 500 meters, then it can start dissolving into the seawater. But actually, huge proportion of the CO2 that we emit to the air today goes into the seawater, but it goes to the top layer. So we have 200 meters of seawater at the top layer, which is containing most of the CO2 from the atmosphere. The problem there is actually that and this sounds a little strange, but you actually put more CO2 into the water by emitting it into the air than you do it by putting it down, because the thermal layers of the sea will make sure that it stays. If it dissolves, it will stay down in the water. But you can say this is not a scenario that we are working so much on, because as our take on this is that they should be inside the seabed sediments, and down there they will. And this is what we're getting work on in order to confirm that down there it will stay for at least 10,000 years. And by then we'll probably have found many other solutions a long time before.
Thank you, Jan. Also, Rajesh, he has a question for you. He is asking, what are the major challenges faced by decarbonize in this project?
Right now, we are very focused on the carbon capture technology. We need to make that work at a reasonable cost. And the technologies developed for carbon capture that are working and in utilization today are probably not that well suited for us. So we're looking into ways of catching carbon in efficient and cheap ways. And that will be kind of a game changer, because if it ends up being a very complicated, large equipment that costs tons and tons of money, then the ship owners will not buy this. So of course we need to make it sure that it's actually a compact system that has an acceptable level of decarbonization. So I would say that is technically the biggest challenge. Then another challenge we're working on is on the ice properties of the CO2 dry ice when it enters the water. So it will be, of course, very cold. So when you throw something very, very cold into a hotter atmosphere, then it can crack and so on. So we are also looking in ways to do this. But so far we have actually not encountered any showstopper. Every time something occurs, then we actually have managed to find solutions on that. And then we also, another thing is that we also need to make sure that we don't hit a submarine underneath, or on a more friendly way, do not hit a whale. So we also you can say you also have environmental concerns as well. But we are looking very serious at this, of course.
Of course, very, very important. So, but when do you think that you're gonna present this for IMO?
This year, after the summer. We would have presented it in April, but due to the corona situation, the meeting at the IMO was postponed. But then it's really a long-term thing, right? So we will start by presenting a paper for the scientific committee, and then hopefully and most likely they will say that this sounds really, really interesting, because we might have found a cheap way of decarbonizing shipping on a short term. Which is also safe, and I think it would be strange if they don't think that this is a really interesting concept. But of course, then they will require from us both. They will ask us a lot of very tough questions that we need to answer, and that will require, you could say, more funding in terms of getting researchers and companies working on the solution. So we're looking at a range of years. You can say decarbonization is on a fast track right now. Or at least was until some months ago. So that could push for a fast procedure, but still it will take time to get all the member states and the flag states and so on to agree on this.
So are there any competitors to decarbonization project, a decarbonization project like this? Is it now you have described it as an open source project? What about this situation about having it open source? Other people are working with other decarbonization projects. You're just come on, work with us, come in.
Since the MDC is a non-profit organization, we ourselves are not in it for getting the profit here. We really want to get this solution out to work as fast as possible. And you could say I don't think we will see that right now, but by far and sure, if we get the permit from the IMO, we will see a very tough development in this area, which is fine. I mean, otherwise it will not fly. So we really need to see a lot of competitors entering the arena. But for the time being, I think everyone is on this boat, you can say, and let's see what happens on that. But I haven't heard of any competitors yet, but I'm sure they will come, and that's how it should be. What we're providing our members is that they get access to kind of a very early stage of the development, and that has value, of course, and also getting the solution approved, because basically I would say our biggest competitors are other solutions for decarbonization. So I guess currently the hype is a lot on ammonia, for instance, and so on. But we really don't see us as competitors for other of these solutions. So I think we can collaborate with them. Sorry?
The last yes or no question. I see you have a lot of partners. Is there space for more partners?
Absolutely. We are always looking, the more the merrier. We have already a global strong partnership, but we are very much interested in both more ship owners and also companies that can help us develop the carbon capture technology. And that will be both inside the shipping and maritime industry, but also in other industries, like the gas industry could, for instance, be one of them that we're looking into.
So an invitation to all of
Absolutely.
Listening along today. If you know anybody who could be interested in joining in this, just reach out to Jan. We will put your email in the chat, and also afterwards you will have an email with the recording of this presentation and how to link up with Jan, and you will be able to write to him if you have further questions. So Jan, I'm saying thank you for your contribution today, and thank you to all of you listening along. We will have a tidbit tomorrow about circular economy with Rasmus Elsborg, who already did one tidbit about circular economy, but it was so popular, there were so many questions, so we decided to make like the advanced course, and that will be tomorrow at 12 o'clock. And then on Thursday, we will have a tidbit about oh, there is a strange echo. Reconstruction and other problems you can have with your customers and stakeholders in these tough times post COVID-19, that you might struggle to get your products or to get your money for your products. So that's what we are having Christian Nistel to help us with some tips and tricks about how to handle that if that should be a problem. And that's on Thursday at 12. So I will just once again say thank you to Jan, and thank you to all of you for listening along, and have a wonderful day. It will be beautiful sunshine, at least here in Denmark. So enjoy the day. Bye.
Thank you. Bye-bye.